Okay. So as we begin to introduce more things into the class, I just want folks to look at the student help session, fill it out with your availability so I can put some times in. We do Zoom and then I record it. So if you go to modules, you will see this. And if you click it, this thing will take you to a website called YouTube. Familiar? I post every lecture there, so you can rewatch them if you need to. The content calendar is what you've already used and signed up with, correct? And we'll talk in more detail about CoCalc today. Is there questions before Elliot gets started? Yeah.
CoCalc, I don't see where I don't see like about that for her work project. Don't see that.
We'll get into that. Yeah, no worries. Sarah will be our LA. She's not yet able to get to class, so probably Wednesday, maybe next week. And then we'll have two people in class working together. Any other questions? Okay. Everyone do the reading? Everyone have the book? Get it online for free?
I put it in.
Okay. Good. Where do you want to start? You can stand if you want. You don't have to.
Do you want?
You can use the pointer if you want to. I mean, you know me. I'm ambulatory, so I'll do this the whole time in class. I'll use multiple boards, everything. So it's whatever your prerogative is.
We don't have to use the pointer.
Okay. Green button. Let me know which page you want to see.
Sure, thank you. Cool. So today what we're going to be working on, it's labeled as if and what is it? On the schedule, it's labeled as if and when, but it's actually we're going to be working with if and while statements. So just wrapping up on what we just finished talking about, we covered different functions, different arithmetic that we can use that are built into the program, and also packages that we can install via the import function. And then there are smaller packages, obviously, that are called modules, which are just like smaller subcategories of these sort of packages. And that just gives us a lot of functions to work with so that we're not having to just use just the built-in ones. But all these built-in functions, they're pretty linear for the most part.
What do you mean by that?
When I say linear, I mean that it's sort of a one and done sort of program where we ask for it to generate a value and it generates it. So the importance of what if and while statements are is that it helps us to break away from the sort of linear path of Python that allows us to not only create conditions for our functions, that is to say that it starts to ask more questions. The rocks start to ask more questions of what it wants versus just generating what we tell it to generate. And also it allows for several of these sort of things to be carried out in a single block.
Good. All right, so let's pause there. Do people have questions on that? So we're moving away from it doing just what we want it to do. And now we're going to add conditions. Okay, everyone's tracking? Keep going.
Cool. So the first control that we can do is if. So what is the if statement? So essentially, whenever we put in an if line, it essentially is asking the program that it's telling the program that now we have a requirement for a certain program to carry out. What if statements do is they create requirements for a set of like functions to carry out. And if that requirement is fulfilled, it will carry out that function. And what's important about if statements is that if they're not fulfilled, then it'll skip it. So the way that we sort of generate those sort of if statements are using the line if, and then we can use any usual arithmetic that we have already. So like for this example here, we have an input. So notice that it's an integer, an input, and we have a statement that, oh, we're asking for a number no greater than 10. So the way that we sort of follow that line is we create an if statement. We have the arithmetic that says x greater than 10. And then notice this indentation that happens. In the book itself, it says that the usual like indentation that you is like rule of thumb is like four indentations for some reason, but it doesn't say that you have to follow that. What matters though is that you have to indent the next functions if you want it to follow your if statement. So once you have your if statement, you basically can create a line of, you can create a separate sort of string that happens once you have that if statement fulfilled. Like for this example, you see that if our x is greater than 10, then we can print saying, hey, you entered a number greater than 10. Let's try that again. And then we have an input. And notice how we leave the indentation into just the normal print again. So why is
So
this?
let's pause for a
Yeah,
second
let me
here.
pause.
Yeah. So go ahead. So this is great. And the way that Elliot's describing input output, right? We create some function here and then we do something with it. I just want to note, so this indentation, as you mentioned before, that really matters. So we saw that, for example, capitalization matters to the computer. So spaces and tabs mean something, right? So this is, and we'll talk about this structure in more detail later. This is essentially a comment block. So if, for example, you had an if statement and you only put one line, and then the next line is over here, then the if statement doesn't know that this second line is part of it. The if statement only knows what's in the indent. And so this statement, is it going to be printed no matter what? Yeah, no matter what, this is going to be printed. And this will only be printed when the argument here is true. Okay. Now, Elliot correctly pointed out, because at this point in the book, we're only thinking about numbers and relationships. So for example, is the number 10 greater than, or sorry, is the number x greater than the number 10, right? And that is a statement that's called a Boolean statement, true or false, and or. You've heard of this before, like logic gates? Okay, so the only thing that if cares about is whether or not this argument is true. It doesn't have to be numbers. You can ask, are two strings the same? Right? You can ask, is the time 12:33? Right? As long as this thing says true, then you're good. Does that make sense? Okay.
Cool, thank you. So that's a pretty basic example. So the importance of if conditions are that if this condition is met, then the function is carried out. If it isn't met, this whole section that's indented is skipped. It's entirely skipped, and we just move on to the next line. You think you could go to the next page?
Yeah.
Thank you. So, like we see in this example up top, we see that we mess up. We put in 11. So then the if statement is fulfilled. So we get this whole spiel that says, hey, let's fix this for you. This is actually your number. So that's the behavior that you can achieve with the if statement, not to drive straight from the book, but that's basically what if statements do. They create conditions. And the thing about these conditions is that you can also use additional criteria for ifs, that is ands, ors, elses, and then something else called an elif. I'll talk about an elif in a second. But and, or elses work basically in the, they work for the actual if statement, depending on where you put it. Or statements, same deal. it makes it so that it's a comparison. And statements, it makes it so that it's a sort of additional sort of condition.
Okay, so let's pause here for a second.
Yes.
So I want folks to think about this. And now someone who's not Elliot, okay, in thinking about it in terms of true and false, what does the top line say? Not what does it read, but what does it say in terms of true and false? Right. If this is true or that is true, right? And what about the second one?
If both are true.
If both are true. Good. Does that make sense? Okay. Yeah.
And using that same Boolean logic, what else's do is if the thing is not true. So you can combine these two different criteria with an else statement so that if your condition isn't met, then you can create another function that happens. So if the thing is not true, else, then something else happens. So if the condition here is not greater than 10, guess what? You're just fine. So yeah, that's not a problem. And so breaking off from else statements, you have elifs, which are here at the bottom. Elifs are special because essentially they're saying else if. So it's telling the program to try another criteria. So in the same way that else's create another function after the if statement is false, it's telling the program, okay, this was false, let's try something else. So that's what elif criteria are. And that's basically what if statements are.
Okay, so can we pause here for a second?
Of course.
So I'd like to ask the class, not Elliot, let's say the number is 9.2. What is the output you get? For the last if else if statement.
Yeah.
You should get 9.
So I thought if you don't have a decimal in 10, then it wouldn't spit out a decimal.
Right, so let's say you put in x equals 9.2. And then you run this.
I would say that it would print the middle one.
The middle one, right? Because first it would look at this one and it would say true or false. False. So it skips this line, doesn't print it. Then it says, is this true? Yes. So then it prints this. Does it print this?
No.
No. So this is why the conditional statements matter in this order, right? Because else won't print if any of these are good. And if this was good, would this print?
No.
Right? How many elifs can you have? As many as you want. Good. How many elses can you have? 1. Do you have to have an else?
No.
Good. Does that make sense? Okay. Good. How are you feeling? You want to keep going? You want to talk about while statements? Okay.
Is everybody doing good so far?
Okay.
Cool. Oh, what's up, man?
Oh, sorry.
I don't remember where, but I noticed the line in the book that said like, oh, unlike stating x equals 1 by itself, where you can like put spaces to make it pretty. Sometimes that doesn't work when you're doing if statements because like indentation, if you have 2 different indents, you get a indent error. If you have no indent, it just won't read it. What's another example of when the spacing matters? Because I tried like, oh, instead of x is greater than 10, x space greater space 10, and it just does the same thing. So I was thinking, oh, maybe we give an error, but I don't.
Like in here. Yeah. So what just so that we're all using the same language, what you're talking about is called white space. So whether that's the space bar, whether that's enter, whether that's tab, that's all considered white space. The computer reads that. And for every location where there is white space, it does something, right? So to your point, in this section here, the X and the exclamation point can have any number of spaces between them. They don't care. but the exclamation point and the equals cannot. They have to be adjacent in order to be recognized as the not equal symbol. This one here, the equal symbol, is very unique. That is not an assignment operator. That is asking if the two are the same. Right? So it's actually a function. Whereas this one here, this is greater than. That's a function, but we don't use it in other contexts. Whereas when we use one equal sign, it's not checking to see if they're the same, it's assigning it the same. Right? So you will make this mistake, I guarantee you. You'll do an if statement, if x equals 1. And you won't add that second equals, and then it'll always be true. Right? Yeah, you're going to make this mistake. The assignment operator, which is equal, versus are they equal, which is equal. Does that make sense? So if you ask the question, are they equal, but you say they are equal, you'll get it wrong. Right? Okay, go ahead.
Yeah, thank you.
Did that answer your question? It's Will, right? Yeah. I'm going to try and learn everyone's names. I'm horrible at it. We're going to try.
Yeah, thank you for that. I knew that was a significant part. I didn't know when to mention it.
No worries. You got it.
Thank you. So cool. So we have if statements. They're just sort of criteria that they ask once, and if it works out, cool. If it doesn't, then it's ignored. So what are while statements? While statements are kind of like if statements, but they act a little bit different. While if statements only check the condition once and skip if it's not met, unless otherwise stated, while statements continuously check the condition. So in a while statement, it will check if the condition is met, and it will loop the whole function back to the beginning again to see if it's still being met. This is what's known as a while loop. This is like one of our first introductions to loops, which we'll be talking about next time. But a while loop essentially is useful to ensure that a condition is met. So what do I mean by that? So we can still use additional criteria, so ands, ors, and also there's no such thing as an else if, but there are else's. And there's two other additional criteria that I'll talk about. But let me break down a while a little bit better. So we have so in this example, we have an input. It's an integer, there's a sentence, there's our input. So instead of saying if x is greater than 10, then we have this. It's asking while this is true, print this out. So as long as this is true, you're gonna get this. And then you're gonna have obviously what's printed at the end either way. So the difference that happens is that when we put this in, it's going to continuously loop this function until we get it right. So we can create a sort of program loop that happens until we finally get the condition right.
Okay, let's pause for a second.
Yes.
What's a real life example where you've seen something like this? Yeah, right. What does a password do? Yeah. I checked your password. That's not it. Try again, bud. Right? That's it. That's a while statement. Okay. What's another one? How could you use this in your computer programming? Can think abstractly here.
Like you get sig figs. You get like hey, your answer still has too many sig figs, try again.
Sure, yeah, you could use it for error modification, right? You'd be like, oh, there's way too many numbers here. I only wanted two digits of precision, right? What about for physics? Anything like, can you use this for math or physics for any reasons?
I do have a question.
Yeah.
Is there a way to like limit how how many loops you can do? Because I know in passwords it gives you like 4 loops, right? Is there a way to limit how many loops you can do until it's like you're locked out now?
There is, that's great. It's the next statement.
Oh,
So it's here, it's called break. So if x equals 111, stop. So you get 110 tries. But yeah, so you'll get there. Another example, and you'll see this. For example, if we want to solve, say, a system of equations, let's say we want to understand the vector potential in a square. And the only thing that we have is the charges inside. What we're going to do is we're going to solve the equations until they satisfy the Poisson equation. That is to say, the right-hand side equals the left-hand side. And what you can do is you can just run the equations over and over and over using a while loop, for example, until the difference between the left and the right-hand side is as small as your uncertainty, whatever you want it to be, say 10 to the 4 or 10 to the -8, right? Something like that. So we can use computers to get approximately close to an answer. How do you calculate the square root of 2? Keep trying numbers, yeah, right? So depending on how close you want to get in that approximation, you could set some uncertainty, and you could say, while that uncertainty is smaller, than some target value, keep running that calculation until you get the right answer. Does that make sense? So it's not just input output. Okay, go ahead. I guess that's kind of it. Do you have any more? Because you're not doing break, right?
Did I?
Oh, yeah, maybe. Hold on, you might have break. How much more is this?
It goes until it hits the Fibonacci example.
Oh, okay.
I'll speed up.
No, you're good. You're good. Yeah, let's not do the examples right now.
Sure.
Talk quickly about break.
Breaking continues?
Yeah.
Sure. So there's no else if criteria, but there is something called a break. So in the same
So
way,
sorry, let's clarify. There's no else if criteria for while.
for whiles. Sorry. Yeah, there's no elif criteria for whiles, but there is something called a break. So what a break does is it essentially stops the loop. That's what it does. Whether or not the criteria is met or not, it stops it.
Good.
And similar to that, there's another, if you want to go to the next page, please.
Yeah.
Yeah, sure.
can you go back real quick?
Oh boy.
So you see in the while, it says while x is greater than 10.
Yeah.
Right, but then right underneath it says if x equals 111. I'm understanding that as if I put in an answer, or if I put in my integer that is 111, then it's gonna break. That means one try, right?
Yeah.
But I like what I interpreted you said is that you said I have 111 tries. But
Yeah.
I'm understanding is that if I put in the number 111, that's when it breaks.
That's absolutely correct. Okay. So your interpretation is correct. What I'm saying is that we can use a break statement in that way. But what you'd have to have is you'd have to have a counter.
Yeah, that's true.
So you'd have to have something like an attempt counter, and you would write, while x equals 10, and before that you would say attempt counter equals 0, right? The first time it runs, you'd say attempt counter plus equals 1. That's going to add 1 to the attempt counter, and then you'd say something like if attempt counter equals 4, break, right? And that's when you lock someone out of their account, or not. You could do continue or something else, right? That makes sense.
Yeah.
Yeah, just adding to that point, you can have if statements in while statements and while statements in if statements. We'll see that in the examples. But something to know about the difference between else's and breaks is that else's occur after the failure of the while statement, whereas breaks can occur regardless of a success or a failure. But something to note is that you can't have an else statement, or rather, an else statement won't happen after a break. Once a break happens, that's it. The loop is closed, regardless of what happens. It just tells the program to move on.
Yeah, so let's think about this really quickly. So here we have something, right? This is the code. It has some loop in here. If I add a break in between these two lines, okay, and then I put in a number that's greater than 10, let's say 30, what do I get out? I put a break in right here.
You're gonna get that print, this is greater than 10. Please
Good.
try again, but you can't try again.
Right, and will it run? No, it'll just end right there, right? So it'll act exactly like an if, just ran once.
Wait, but, you said even if it's right, you would also like. Stop the loop.
So let's think about the structure of the if else statement, right? Let's go back one here. So what this does is first it checks, is this true? Is this true? Is this true? Other than this, sorry. Is this true? No. Is this true? No. Do this, right? Whereas while isn't asking that. As soon as it goes, let's look at the structure here. It says, is this true? Then do this. Okay. Now check if it's true again. Right?
Okay.
Now check if it's true again. So it keeps doing that over and over and over and over. And unless you tell it how to stop, it'll run forever. Right? There's no else for it. Right? There's no like, you did it 14 times, automatically break. Okay. Good.
That's pretty much it. Continues, if you want to go to the next page.
Yeah,
There's not really.
let's just talk really quickly about white space. Since we're looking at it here, and this is normal. That's one indent. That's the first layer or the first nest. Okay, and then I tab in. If I tab in one more time, this break is due to this statement only. Right? So it only happens in here. But this break doesn't happen to if. Why does break not happen to if?
It's the running code in if.
Because sorry, say that again.
It's the running code that's in the if statement.
I might say that a little differently. When you say running, you mean like the loop, or you mean like
Because the if statement only runs once.
there you go. That's what I would say, right? Because the if statement only runs once, you don't need a break to undo it. Breaks are designed for loops. So here, while is a loop, a conditional loop that runs over and over and over, right? And that's why we need a break. The break assesses the loop. And the break only breaks out of the loop, not of the if statement. Okay. Good. Cool.
If the while loop were in another while loop, it would break both of them.
Yes, I believe it will. Let's double check. While loops nested inside ifs are allowed. Doesn't stop at 2 levels, any number of statements.
That's the best.
We can try it. I always tell folks, the best thing that you can learn how to do in this class is to break your computer. Okay. No. Not like, ruin your computer, but you want to like push the boundaries of what can your programs do, right? You can learn how to be a better programmer. Obviously, you'll break it in the beginning because you'll just be doing it poorly. But at the end of it, you'll be like, oh, I'm actually figuring out, remember how we played with those numbers where 0.99999 suddenly became 1? You're finding out about the boundaries of the machine you're using, right? And so you've got to find out the language too. So let's pretend like I didn't give you an answer for that question, and let's do an experiment, right? In the first part of today's class. Okay. Elliot, anything more you want before we turn on?
Continue statements aren't used often. All they do essentially is all it does is it calls for the program to skip your indented code all the way back to the very beginning, the while statement. I can't exactly think in my brain where exactly it's used, but it is useful if you want to try and go back to the beginning.
Yeah, so there's philosophical differences, and this is why I think it's important to learn how other people code as well. We're going to start with ifs and whiles, and then we're going to abandon a lot of whiles. Whiles are very They're used in very specific contexts. Ifs are used all the time, and more importantly, fors. So understanding how long your loop goes is pretty good, right? You don't want your computer to run for infinite amount of time. Does that make sense? It is very easy to make your computer run forever. You will do it. I promise you in this class, you will make it run forever. Okay? So let's do it. Let's start breaking our computers. The first thing I'm going to have you do is everyone's going to stand up and they're going to find someone new they've never talked to in class, and they're going to work with that person instead. The person you're sitting next to is not the person you're working next to. I know, because friends always sit together and I always have to break them up. Hey, relax. Be kind. Okay. Every other person should stand up because one person can stand and one person has to sit.
Just stay here, so I can just use this.
Sure.
Also here.
Oh, that's
But that wasn't too.
yeah, it's perfect.
On mine. Oh my goodness. Oh no. That's you.
No, that's not true. Oh yeah, it is odd. Okay, Lucia, why don't you come in between these two? Okay, so we have one super team. Also because Elliot's, the one who did the presentation today. But they have more manpower, but don't worry, it's not a competition. Okay? The point of ungrading is that it's not a competition. Now, yeah. That's a good idea. Let's do that. Yeah, do you mind going back there? Yeah. Okay. So has everyone opened CodeCalc? You can see that your name is associated with your person. Okay. And so now I can assign pair programming to you. Hopefully this works. And you should see a little folder. And it should say the word pair programming. Okay. So let's see. David, can I open your folder? Is that okay?
Sure.
So let's open it. There's nothing in there. Just kidding. Starting up. This thing like to log out when I'm talking. Okay. So there we go. There's week 1. And if you go into week 1, you can create a file. And David, I'm going to create a file for you. Okay. You go in here. See all these little ones? Which one do you want? Jupyter Notebook. Very good, folks. Okay. Now, what do we want to name it? Not project. This is not a project. This is pair programming. So you could say pair programming 1. You could say pair 1. I'm going to say test. Okay. Because this is not David, it's me. Okay. And so now there's a file. You will both be working together, but you will not have 2 computers with CodeCalc open. So the way that pair programming works is that one person is the navigator and the other person is the driver. The navigator does not touch the computer. The driver does not do all of the thinking. The driver is focused on the code. The navigator is focused on the implementation. Okay? So what I mean by this is you're going to have a problem. Let's say we start with one of the examples for today. Let's say we're going to write this one out. Okay, we want to write out a sequence of numbers. I mean, this is a worked example, but they want to write a sequence of numbers that says start with 1 and then add the previous number to it. So 1 added to 1 is 2, 2 added to 1 is 3, 3 added to 2, so on and so forth. Okay, so you're going to work together to think about an algorithm. You're going to write it out sort of broadly, sketch it out on paper, just how one step should go to the other, how it should go to the other, like that. And then one person is doing the typing and the other person is basically sitting next to them saying, wait, that's not quite right. Let's add the letter here, or these are the same words. And that way, 4 eyeballs looking at the same code is less likely to break. Does that make sense? Okay. You should talk to each other. So you should introduce each other. Like, hi, my name is blah, blah, blah. At the very top of your pair programming, I would like to see the following sets of comments. Okay, oops, don't generate using AI. I would like to say navigator driver. Okay, you'll put your name, whatever you are, and your partner's name next to it. Okay. Then when you are switching, tell me that you've switched. Okay, so let's say you start and you do the first 30 minutes and the person's like, hey, I'm getting real bored of this. I think you should switch about every 20 or 30 minutes. Okay, and all you have to do in order to switch is just pass the keyboard and mouse over or switch physical locations and just indicate where you switched, right? So let's say you finish problem 1 and you're moving on to problem 2. You say, oh, problem 2, we switched. Does that make sense? And you can leave whatever notes you want here. So you can be like, hey, by the way, this class sucks and I hate you, right? And I'll see that. Does that make sense? Okay. Is this okay? We'll talk a little bit more about the front matter. That's the stuff that you write at the beginning in order to indicate to the person who's reading it what they should be aware of, right? But traditionally, the front matter has at a minimum the name of both of the people, the problem you're working on, right? And then you can have any notes. You can be like, we tried to get the code to run, but we kept getting this error. Just leave that right in the front matter, and then I'll look for it, right? Okay. So what are we doing today? Good question, Krismani. What the fuck is the... All right. Okay. Bada bing, bada boom. We didn't do this, right? We didn't do 2.1 as a pair exercise. So let's do 2.1. And let me show you how we're going to do this as a group. Okay. That's 2.7. That's way, way too far. Okay. All right. Oh, God. Can you see it okay? I'm going to do single. Yeah. Mark Newman, Newman. Yeah. Okay. So exercise 2.1 that you're going to do as a pair is straightforward. A ball is dropped from a tower of height h with a velocity 0. Write a program that asks the user to enter the height in meters and then calculates and prints the time the ball takes to hit the ground, ignoring air resistance. Use your program to calculate a time for a ball dropped from 100 meters high tower. Does everyone feel like they can do this right off the rip? No? Raise your hand. So there's 2 places to start. First, write it down on a piece of paper. I'm going to say this a million times, and you won't do it until like 6 weeks in. You're like, oh, damn, I guess I should have started doing that. Okay. Write down your knowns and unknowns. Write down what you think are the appropriate algorithms. Draw it out, right? So if I were doing this problem, I would say something like, all right, there's a picture. I need pictures because that's just how my brain does. You have some dude or person holding a ball. The ball has 0 velocity. Okay. And this is some distance h for height. How do I find the time?
Use the kinematics equation and solve for t.
Good. What's the kinematics equation?
X of t equals h plus, I guess, 0. Or
Yeah, I'm gonna write just the kinematics equation first, and then we'll simplify it.
b times t
Good.
plus 1/2 a t squared.
Perfect. Okay, so now this is
Gravity.
gravity. This is good. And then h is that, right? Okay, so I can say h equals 1/2 g t squared, which means that t is the square root of 2h. Bada bing, bada boom. Good, so it helps to work the math out. And now I need to know what I need to ask, right? So I have the math. It says write a program that asks the user to enter the height in meters. So what comes into the program? H. And what goes out? T. And what doesn't matter? Like what's not in or out? What? G. That's called a constant. Okay. So we add these two, and then it gives that. What statement will we use to give this? How do we get this?
Input.
Input. Very good. Okay, this is the input function. Okay. And then just math. How do we get this? What? Print. Cool. Should be this small. Good luck. And you're going to do multiple problems, so don't just like do one and then bounce. We have a lot of problems today. I have you till 3:30. Yeah. If anyone, by the way, wants to take a bathroom break or go get food, you're welcome to. I'm not like a, you know. I have snacks, and I have to move my car still.
What's the difference between navigator and driver?
What?
What was the difference between the navigator and the driver?
The driver tells the navigator what to type. The navigator, the driver types it. Yeah, we won. Yeah, so you won't all be able to see it. This is only in his folder. That's why it's so important that you name who your friends, right? So if, for example, you wanted to have 3 computers open, which I think is not a great idea, I would not write the same thing over, right? That's just duplicating everyone's effort. Instead, if you're all looking at one screen, then you can see where the comma is missed or a period is missed, right? Now, what you can do is, let's say you navigate first. If you want to use your computer after, you could do, say, problem 2.2. You're the driver and the navigator, and it's on your personal, right? It doesn't have to be in one document. I can find references. Yeah, you can also just do pair programming in one.
Oh, you want to start?
They'll put a comma.
Sorry, sorry. We put it below because we're gonna do multiplication.
Oh, this is.
Oh, you'll see. This is gonna be.
Yeah,
fun.
but at one time it's too funny.
That's fun.
If we're gonna do multiplication.
All. This has this kind of this, all that.
But I can.
So then this becomes a negative.
Different like math related equation files.
What?
Oh.
Cause I wanted to input that equation, right? But,
We have this.
So we have.
I don't know how to explain it. Because there's like different square files.
Functions, packages,
Yes.
and modules.
Can't they just bring in a package and then?
Yeah, so in fact, you'll need, which one will you need here? I mean, you could use, or I think, weren't you said, can't you just take it to 0.5? Exponential 0.5? Yeah, so you could do that. Or you could put the math dot square root package in, right? So here you have math import pi, math import x. But again, you can see all these different ones. See the square root looks like that.
Can you say import math or dot square root as square root?
From that.
Like this?
Like no, dot pi is.
Yeah, we're gonna do, I mean, I typically haven't got this yet,
SQ.
but I usually do import. Right, and then that'll have.
Then moving on. We want to create it.
But you don't know that.
Functions.
No, you can,
Put another.
but this is how you
Yeah,
add
enter
it.
again. So
But you
there's like
couldn't
a-
say as empty that until you
Then
shorten
go
it.
ahead and create it.
So you could say import.
And then.
And then square root will just exist.
Can you import non square root as SQ?
Yeah.
Do that.
That's not or forgot
Okay, I have to move my car. Is everyone okay for 5 minutes? You saw how fast that was last time, right? Yeah. Fast.
I only know like.
Oh, sorry.
Okay,
How long?
They never showed me like very basic.
And I put height.
So like, I just know like random stuff, yeah, so.
And then.
And then you can do nine.
And then do. location.
That's it.
Please enter.
Then we can say.
Height.
Well, we're gonna want it. Oh, that's.
Do
you want to use that or do you want?
So we can do.
And then afterwards, we can use
SQRT.
put the colon
um,
space. And then let's try to run it. and See how it works. Yeah. Yeah, so where's the button there?
Or should I put it?
Oh.
Yeah.
That would be in parentheses, your state.
Oh, that's fine, that's fine. Oh, sorry.
What's the statement?
Go right here.
Oh.
Enter, print height. Oh, put the, parentheses. Let's run it.
44 in the PDF, 42 in the PDF.
Oh, so that's, these enter the height meter, so the put right on the shapes.
Oh, so close.
No, it's fine.
That means everything.
No, it's, I mean,
Yeah, well, it's
still like, so then enter.
What?
oh, it's stop. Yes, it is. Oh, wait, no, it's gone.
Oh, yeah.
Okay. They mention the height of a tower.
Do it again.
Of a tower.
So you have to run it again.
Enter the
Run.
height.
So.
Oh, that's right.
So we want.
In a tower.
So now, I don't trust you. What is it? Like,
What if you put right here, right here, type the,
And you also need a colon and a space.
yeah, I just want to try.
Wait, no.
That's all right.
That way, like, I do it, so like, I don't do it.
So after the parenthesis and before the double quotation.
Oh, that works.
Oh.
And then put 10.
The watch doesn't know that.
Okay,
So then if I.
so that's what we do. Notice how like I said, please enter the thing.
Then-
So keep it,
Other one,
keep it like that.
Put a colon.
Let's do it enter right here.
Then in between.
So we have the height and then from 1 to. Right here, do time.
Space. And then it's gonna,
Yeah.
when you run it, it's gonna ask it. And it's.
So then do we do five?
Yeah, okay, so that's what we need. So then right here, we can put enter.
Or. where you
Uh,
command
Can't they just,
Wait.
yeah,
G.
G is equal to space. Spacing, yeah. Segment.
Yeah,
And then.
oh, maybe this.
And then do, T is equal to. Is equal to, is QRT. Parentheses. So parentheses again.
If we make.
To,
oh, wait, input.
So that if H equals X,
no, no, no.
Spell it.
One more. Star.
and then we have. Value, and then we have the equation.
I did it wrong.
X, you can still get input value for.
And then, so outside of the parentheses.
Yeah, maybe it's a little.
Yeah, and then X slash.
Nine.
Oh, yeah.
Because it's H.
Oh, yeah, yeah, yeah.
You put that.
And then. There we go.
Oh.
Oh, sorry, can you put T as the just put height.
Oh, yeah.
And then it should work. So let's run it.
Word.
I feel, because then that makes sense because.
Yeah, let's put like
Would it make sense to put it before that? Because if we do. Then it's right, okay, X equals H. But then we don't-
Oh.
Oh.
No. Let's start right now. Oh, I don't have my calculator.
Oh, wait, that's one.
Are you just gonna?
Oh, equal?
No, put it back. It's right, that's right.
No.
That's the math.
And.
Oh, that's.
No, that won't work. It's the pipeline here.
With a B.
And then, let's say.
Yeah, put a space between, the equal sign and.
For the sake of,
Before they making it pretty.
and then you need a.
Oh, yeah.
That's, yeah, right here. I don't know if you wanna put height or age.
Yeah.
Then.
I needed I need that.
Is that true?
I need this.
Just
Just kidding.
Okay.
Space.
No.
Let's see.
Good. Okay, so now what you want to do is you just want to add a little bit of comments saying, yeah, we checked it with the computer, it worked like it was supposed to. Okay, because you'll notice that in the rubric for the class, every piece is supposed to have 4 things that it's graded on. 1, does it have an algorithm that's attempting to solve the problem? 2, does the algorithm run? 3, if it ran, how do you know that it gave the right answer? And 4, does it look good?
We can put.
Oh.
I don't know what mine to go.
Okay. I believe the second pair programming is 2.2. Yeah.
Okay. So you. Pretty much received. I think now we can just.
But I would recommend, especially if you have a navigator who has a computer open up the documentation for Python. Anytime you're using a function, just make sure, okay, what's the exact thing about them? So usually what I'll always do, it gives some like technical stuff that I don't understand. You scroll down, there's like.
Right
Right,
here.
the compensation.
Is it possible that?
Okay, and then once you finish 2.1, switch. To 2.2.
Different one or the same?
You can just hit enter and it will, yeah. The T equal right here.
Ensuring that the value.
Let's see.
Right.
Okay, I understand. But it's a, this, it's thinking it's a string. Right here, we have to put and then, and then,
We have a call.
To ensure that.
and then
Stress.
That's.
H, capital H.
No.
And then, slash. Capital G. And parentheses.
Yeah.
Double asterisk.
So, it's just take the.
0.1.
Yeah, so then we can put it, and then put,
Right.
and then space, and then do. And then put.
And then another one on the very right. And then on the very left. And now outside one, so.
I don't have no idea how to.
Just great. And then put the. Yeah, you want to put that? Or you can put I would. I would like to. Instead of. Quotes.
Where?
Yeah, but it's a backspace on the team. Then. Not a problem. And then comma. Somewhere I can find T.
Oh,
So.
wait.
No matter what T we give, it'll give you. Does that make sense? So we give you, we give it a different. Between the. Oh, right. You put it. And then, so right once. And then right once. And then, right, space. Yes, big.
It's telling me that it's like.
So I would put,
telling me it's wrong.
space, seconds. Yeah. For the ball. This downward. Takes the order, the radius to this.
Maybe just one quote.
Oh, we don't really know.
Did you close that?
So it's like you put two birds.
It's alright.
One, two. All right, you
Oh.
Don't forget to use the color of the parentheses to tell you whether it's closed or not. I'm just saying it can be helpful. I'm not saying that you weren't. I'm just shouting to the class, not to you.
These are, they change colors, right? What do you mean you don't know?
I don't want to argue with them.
What are you saying it doesn't change?
I don't want.
Is it a function? A defined function like print?
It's just a quotation.
Oh, quotation marks don't change, but parentheses do. I said parentheses. What did I mean to say? Or sorry, what did I say? I meant to say parentheses. Okay. Got it.
Pretty frustrated.
Make it move over the right side. I'm sorry, too far.
See, it always want, it
That's
comes
the
in a
way.
double.
One star, you can have both ones.
Correct.
I was trying to see.
There you go. So make it the right. Well, the right. I mean, it might work, but
That is literally what it.
only the right. You have to make it, because you got rid of the quotes, you got rid of the quotes. You got rid of the quotes on this one. The quotes?
We already defined G and R.
And then on this one. There you go, okay. I mean, it worked. Sorry, Max.
Getting it wrong is the process. Don't worry.
Why did that happen?
You're blaming me.
I'm not.
You before you were. You do the backspace.
No. What is going on? We put in put PI.
No.
There we go.
What does it say in the book?
Now.
You can either try from math, import pi, or you can try import math and then do math.pi, or you can do numpy and pi is in there. Depends on which package you want to use.
That means we put in a numpy or np.pi.
Did you import np as numpy as np?
So I use np.pi.
Mhm.
That's a quote.
Now.
Where is that? I think where the match code would be the highest. Okay. Dimension, yeah.
Yeah.
I would feel like this class is gonna make me cry.
Make you cry out of happiness. No, happiness for sure.
Wait, you have to put in, who's the navigator, who's the driver, and then.
And also remember that not only does the code work, that is have the right algorithm, how do you know that it worked? Did you test it? Did you check it? Mention that, right?
Yeah. Yeah.
I think we would.
So I think that's it.
Yeah, we're going to do 2.1, 2.2. That is, of course, Thursday's problems that we didn't do. So we'll go even farther. We'll do the while and the breaks. Did you do 2.2 already? Wow. All right, relax. So make sure that you're switching, right? So every problem should have a new navigator.
Oh, no.
Hashtag and mark. So click this one. Then hit there you go, album. Then hit above. And now. Yeah, now one of them, put in a comment. Hashtag. Oh, or,
That's great.
and.
Okay, that's the back of that.
I would just try,
Oh, and we have acceleration. You want me to- Mass only and forces.
Okay, that looks great.
Sorry, about everything. Well. Kind of doing,
I mean, the thing we're not doing here is doing.
so, you can do, like, let's say if you want to like. Yeah, yeah. Like you do like.
Like,
Power.
yeah, it's really-
No, I'm saying like. Previous impact on that.
Okay.
I'm not very.
Is it just one?
Oh, yeah, you put there. You're so right.
No, it's two ways.
I was gonna listen.
Yeah, we have to do this.
There you go.
All one.
Okay, whatever. You know how to spell, not spell. At least. You're not dyslexic if you understand.
For my birthday? Yeah, usually.
There you go.
I haven't gone last year or the year before because it's just too oversold. It's not worth it anymore. Even when if you're in VIP and it doesn't feel like VIP, it's like, what are you paying for? You're just in Vegas.
Always wanted to go. And I was gonna say, like, Control is the one.
It's the largest. I would say it was a lot better. I go to Coachella. It's more fun by a lot.
I like dressing up, so I like, I don't know the Halloween one.
Oh, Beyond.
Yeah.
Yeah.
I mean, I like cosplay.
Mm,
But I don't be cool.
yeah.
I don't know, so. everybody,
It's certainly worth going to. I mean, it could be fun.
Oh, wait, no.
Then if it's off, they just turn them off.
But I'm just like reading.
Because we're trying to get.
This is what it's going to be. So we can all.
There you go. We're gonna wait for it all.
But so what they want to do instead.
I guess more.
And then here.
Very beginning. Okay. Like 637.
Oh, you want to put the doesn't matter. And I thought we were trying.
Right, and if our answer is right, then we. Like, we're both right. Like this.
Rocks with electricity.
Why?
Depends. Is the variable? If you add extra words, it will fail.
Literally what we have here.
For in a comment,
Like what it tells before you.
oh yeah, that's fine. Input number here, input the number here. Those are fine. Those are it's all about style. So maybe his style and your style are not the same. Not that one is better than the other. What what's the Kevin line? Small word good when big word does trick. Why use big word when small word does trick? Yeah. So funny. That's good. That's true, because they only make them like 10 episodes long.
Can I share, like, the code that we did?
What do you mean?
New collaborators.
Okay, so with that, now we know that this is right, right? Okay, so we try this.
So the only thing is you have to be a little careful there that you're not sharing your entire like project. I'm just saying, just check. Okay, is everyone down with 2.2? No. Yeah. What?
Oh, shit, well,
Like this, and see if that's that. So 4, 5.
okay, so.
4, 5, 3. And like that, and okay, so that means that's right. So then.
No, I changed mine.
Easier.
Like,
One button.
Wait, ready? How many seconds are
Now, you don't have to do all of this. Oh my God, I hate you find examples. But at the very end, you could say, you you know.
Oh. I love it. I love it. I can draw strictly.
So then here, you could say like, oh, print H, and you have a little note, right? And then if you got the right answer, you could say something like, yes, this. Will be. That was for
Yeah.
Sorry. Where the hell did I put?
Yeah, it's just THUC.
What? Oh, don't do A, by the way.
Don't do A.
Yeah. Sorry, just as a rule, anytime it says show XYZ in math, just ignore that. Okay? Use the result. Yeah.
Oh, yeah, that's very. You can put that in there. Okay.
You're helping her navigate though, right? It's not cook in person who eats, you know?
Yeah.
Yeah.
Are we gonna turn in our paper that the navigators use?
Your personal notes you keep for yourself. If you want to say, oh, I did this on scratch paper and it showed that it worked, that's great. But anytime that it says this, show XYZ, ignore that. Right? No derivations and stuff. So you have enough work to do without having to derive mathematical equations.
We don't use So we just do integral to flow.
There you go.
Right? It's
So, 86,000.
Okay,